Hello everyone, this is Dr. Ranjith Kumar Gatla, working as an associate professor in Department of Electrical and Electronic Engineering, Institute of Aeronautical Engineering. In today's class, we are going to discuss about the different types of choppers. In the previous class, we have discussed the different types of choppers, and we have also discussed based on the output voltage as well as the direction of the voltage and current. So in the previous class, we have discussed based on the voltage, which are the step up and the step down choppers. So in today's class, we are going to discuss the different types of choppers based on the direction of the voltage and current. So here, basically, there are 5 different types of choppers are there based on the direction of the voltage and current. So which are the class A, class B, class C, class D and class E choppers. So in these 5 different types of choppers, the first 2 choppers, which are class A and class B, are the single quadrant choppers, and the second 2 choppers, which are class C and class D, are the 2 quadrant choppers, and then the last one, which is class E chopper, is a 4 quadrant chopper. Right. So one by one we will discuss in today's class. So first we will discuss about the class A chopper, which is also called as a single quadrant chopper, and that single quadrant is the first quadrant. So that's why this chopper is also called as a first quadrant chopper. As we can see, the structure of this class A chopper, which is similar to or similar like the step down chopper. Similar like the step down chopper, because in the step down chopper, as you can see, the chopper switch is in series with the source and the freewheeling diode is in parallel with the load. So here, and in this class A chopper, the voltage, the output voltage and current is always positive, okay, irrespective of the value of the duty cycle. So that's why this is a first quadrant chopper and the single quadrant chopper. So then we will discuss about the operation of this chopper. So in every chopper we need to operate the chopper switch. So anyway, here we are having only one chopper switch. So this chopper switch we need to operate. So the operation of the chopper switch is nothing but just to turn on and turn off. Turn on and turn off. Right. So initially, if you consider the chopper switch is in the off, off state, then we are going to turn on the chopper switch. Okay. So that the supply which is connected to the load through this chopper switch. Okay. Then when you are turning off the chopper switch, when you turn off the chopper switch, then the supply is disconnected with the load. Okay. And the freewheeling diode will start conducting, so that the short circuit applied across the load, then the load voltage will be 0. But the load current continues to flow with the same direction through the freewheeling diode. With the same direction through the freewheeling diode. So which means here, when the thyristor switch is on, then the load current will flow in this direction. So here the direction of the current that you can see, which is same as the reference direction, and the voltage is also same. And similarly, when you turn off the thyristor switch, chopper switch, then the load current will flow because of the inductor present in the load. Then the load current will flow in this direction from here to, because here it will discharge from here to here to here. So again, the direction of the load current is same. So in both the cases, when the thyristor switch is turned on and when the thyristor switch is turned off, in both the cases, the load current and load voltage are always positive. So that's why this is a single quadrant chopper. That's why this is called a single quadrant chopper. And when you go for the output voltage and output current waveforms, okay. So here this is the output voltage waveform. So as you can see, the output voltage waveform, okay. So when the chopper is turned on, so during that time you will be having the voltage, okay, because here as you can see, by giving the gate signal, we are turning on the chopper switch CH1, then we are getting during that time the output voltage V0 is like this. Then during this time we are turning off the chopper switch, Okay, so this time because of the freewheeling diode, the short circuit will get applied across the load, so that the load current will the load voltage will be 0. And again here we are turning on by giving the gate signal, we are turning on the CH1, then again we are getting the voltage, and again here no voltage. And when coming to the current waveform, here as you can see, when the thyristor switch is turned on or the chopper switch is turned on, then the current is gradually increasing, and when the chopper switch is turned off, immediately the freewheeling diode starts conducting. Then during this time, whatever the energy stored in the inductor, so that will discharge. Okay, so because of the this inductor effect, there will be a small amount of the load current flow through the load, and so that here the load current is gradually decreasing. Then again, by giving the gate signal IG1, we are turning on the CH1, then again the load current will gradually increasing. Then again, when you turn it off, again the freewheeling diode will start conducting, so that the load current will discharge, and again it will increase. So like this, the output voltage and output current. As you can see, the output voltage is always positive here, and similarly the output current is also always positive. Okay, and here as you can see, the output current equation obtained in step down chopper with RL load can be used to study the performance of a class A chopper. Because if there is no RL load here, the current will be also discontinuous. There is no use of this freewheeling diode. That's why we must if we use RL load, then only we can study the performance of the class A chopper. This is about the class A chopper. Then we will go for the next chopper, which is the class B chopper. So here in the class B chopper, as you can see, which is similar, not exactly, but which is similar like the the step up chopper. Okay, so because here as you can see, the diode is in series with the source, and the chopper is in parallel with the the load. And this is also called as a single quadrant chopper, and because that single quadrant is in the second quadrant, so that's why this is also called as the second quadrant chopper. Class B or the single quadrant or the second quadrant chopper. As you can see here, V0 is equal to E plus L into di by dt, so which is always greater than Vs. Because here to perform to analyze the performance of the class B chopper, we must consider RLE load. Because as you can see, again here we need to operate this chopper switch. So initially when the chopper switch is on, then E drives the current through L and R. Okay, so it is in the opposite direction to the actual load current direction that you can see here. So because here he drives the current flowing through these R and L, so that here it will go and like this. This is the direction of the load current. As you can see, the direction of the load current and the reference direction both are opposite, which means the load current is negative, but still the voltage is positive because we have considered with these terminals plus and minus. So during this time, this inductor will store the energy. This inductor will store the energy in this terminal. Okay, in this terminal. Then when the chopper switch is off, the energy stored in the inductor will discharge. The energy stored in the inductor will discharge, okay, by changing its terminal, like here plus and here minus, then it will discharge through diode D to the supply. So again, the load current direction is opposite to the actual or the reference load current. So that here the load current is always negative. So that here you can see the load current is always negative, but the load voltage is positive, always positive. That we can see even by using these waveforms also. Because here the average output voltage is positive, but the average output current is negative. So that's why here this class B chopper operate in the second quadrant. Then here you can see when the thyristor is when the thyristor is turned on by giving the gate signal. Okay, so there is no output voltage because what is that, the chopper will make a short circuit across the output voltage, so that's why the output voltage is 0. But when the thyristor is turned off, okay, and during this time what will happen, what is that, the current is gradually decreasing. Okay, and again when the thyristor is turned off, okay, then the inductor will what is that, is discharging through the freewheeling diode to the source. So in that case the output current is gradually increasing, but this is in the negative direction only. So that's why here the average output current is always negative, but the average output voltage is always positive. So that's why this is a second quadrant operation. And one of the what is the best application for this class B chopper is we can use for the regenerative braking of the DC motor, regenerating braking of the DC motor. And this class B chopper is a step up chopper. Of course, this we cannot also call as a step up chopper, but this is a step up chopper. By using this class B, we can get the step up chopper operation. This is about the class B chopper. So now we have discussed class A and class B choppers. So in the class A and class B, both are the single quadrant choppers, but the class A is the first quadrant chopper and the class B is the second quadrant chopper, because in the class A, both the output voltage and currents are always positive. In the class B, the output voltage is always positive, but the output current is always negative. So that's why this is a second quadrant chopper. Then we will discuss about class C chopper. So this class C chopper is a combination of class A and class B choppers. This is a combination of class A and class B choppers, because as you can see, the class A chopper is the first quadrant chopper and the class B chopper is the second quadrant chopper. So but here the class C is the two quadrant chopper, which are the first and second quadrant. And by the configuration of the circuit is also looks like same, like here as you can see, the CH1, okay, is in series with the source, and but CH2 is in parallel with the load. So and here the D1 is in series with the load, and here D2 is parallel with the load. So by considering CH1 and D2, we can get the chopper 1 class A chopper operation, and by considering CH2 and D2, we can get the class B chopper operation, right? So that's why here you can see for the first quadrant operation, CH1 and D2 conducts, CH1 and D2 conducts, so that you will get the first quadrant operation. And when coming to the second quadrant operation, the CH2 and D1 should conduct. Here for the second quadrant operation, CH2 is on and D1 conducts. So here when CH1 and is on, okay, because as we know, we should perform the the chopper switch operation CH1 and CH2, which means first let me consider CH1. So when CH1 is turned on, then the load current will flow. Then the load current will flow from CH1 source to CH1 to load to like this. So which means the output current is positive. This is I0, and with the reference to the reference direction of the current, and V0 is also positive because plus and minus. And when during this time the inductor will store the energy with these polarities, and when the chopper switch is off, then the inductor will get discharged, then again with the terminals of plus and minus, by changing these terminals, okay, so that the inductor will get discharged through diode D2 in this way. So again here the direction of the current is same and the voltage is also same. So that's why when the CH1 and D2 is operate, the voltage and current is always positive. So that this is Class A chopper operation. Class A chopper operation. Then similarly, when CH2 is turned on, okay, when CH2 is turned on, then the back EMF, okay, will supply the load current flow through the RL to CH2. So which means again here it is, I mean during this time again the inductor will charge and the load current will flow like this. So which is opposite to the source current. Okay, so the, I mean the reference current. So that's why here the current is negative during CH2 is on. And when CH2 is turned off, when CH2 is turned on, during that time the inductor stores the energy. Okay, and when CH2 is turned off, okay, then the inductor will discharge. Then during that time, here again, what is that? The terminals has been changed. Then the inductor will discharge like this through D1. So again, in this case also, the direction of the direction of the current is opposite to the reference direction. So that's why it is class B operation, because the current is always negative but the output voltage is always positive. So this can furthermore get clarity by using these waveforms. As you can see here, at this particular point we are turning on the IG1. Yes, at this particular point we are turning on the IG1. Okay, so when we are turning on IG1, the load current is positive, and as well as you will get the load voltage also, because the CH1 is make the connection between the source and the load. When CH1 is turned off, then the D2 will start conducting. So during the D2, because when during the CH1 is turned on, the inductor stores the energy, and the same energy will discharge through D2. When the D2 starts conducting, then the load current is gradually increasing to 0. And during this time, the output voltage is 0, because it will make a short circuit across the load. Then again, we are giving the signal to the second thyristor, okay, which is IG2, the chopper switch 2. Then again, of course, during that time also the load current is the load voltage is 0, but the load current we are getting in the negative. And when CH2 is turned off, then the D2 will start conducting. Then this time the current is gradually increasing and it is reaches to 0. Then this will repeat again, so that you will get the the current is negative. Okay, I mean when CH1 is turned on, the current is positive. Okay, when CH2 and D2 are conducting, are operating, then the current is always negative. But the output voltage is always positive, irrespective of which chopper switch is operating. So this is how the operation of the chopper C. So here just I have mentioned some points that you can see. The output voltage is equal to V and the load receives the power from the source. Yes, of course, because the load and source are connected with each other. And when CH1 is turned off, then the energy stored in the inductor L forces current to flow through the diode D2, and then the output voltage is 0. Because this diode, okay, D2 will make the short circuit across the load, so that the output voltage is 0. And the current continues to flow in a positive direction, even though when the chopper switch 1 is turned off, because of the diode D1. Because of the diode D2. Then again, after that, then we are triggered the CH2. Then the E forces current flowing in opposite direction through L and CH2. So in this case, the output voltage is again 0, because here the CH2 make the short circuit across the load. So that's why when the CH2 is triggered and during the CH2 is turned on, the output voltage is 0. And again, when you turn off the CH2, then the energy stored in the inductor, okay, will dissipate through the diode D1 and the supply. Okay, so in this what is the case also, the output current is negative, but the output voltage is always positive, because because the input current is negative, then the power flows from load to the source. So this is the class C chopper. Then next we are going to discuss about class D chopper. So this is totally independent. I mean, it is not a combination of any the previously three configurations. Okay, so here it is totally independent chopper, because as you can see, this chopper having two what is that, switches and two diodes. Okay, so I mean, the class D also a two quadrant chopper, but the class D is first and fourth quadrant chopper. It is operating in first and fourth quadrant chopper. Then when CH1 and CH2 are conducting, okay, then we will get the what is that, the class A chopper operation, which is the first quadrant operation. And when D1 D2 are conducting, then you will get the D1 D2 will conduct D1 D2 are conducting, then you will get the second quadrant operation. That's what here I have mentioned. So when both CH1 and CH2 are triggered simultaneously, then the output voltage V0 is equal to V, and the output current flows through the load. As I can show you, when CH1 and CH2 are turned on, then the load current flow in this direction. So in this way, so which means the load current is positive only, because here it is same like the reference direction, and the voltage also a positive. So during this time, the energy is stored when CH1 and CH2 are turned on, and when CH1 and CH2 are turned off, then the load current flows in the same direction through the diode D1 and D2 due to the energy stored in the inductor. Okay, so that is, before it was storing in this direction, but when it changed and it plus and minus, then the direction of this is like this. So again the direction is same, but the output voltage is get reversed. So and in the chopper D, okay, so in chopper C, we can decide, I mean, based on the operation of the chopper switch, I mean, which quadrant it should operate. Okay, whether it is in the first quadrant or the second quadrant, because by operating the switch 1, then we can get the first quadrant operation, and if you operate the switch 2, then you can get the second quadrant operation. But here in the class D, it is not like that. Okay, so I mean, the operation of this chopper is depends on the value of the delta, which is duty cycle, which is depends on the duty cycle, that we will see here. First, let me consider T on is greater than T off. T on is greater than T off. When T on is greater than T off, then both voltage and currents are positive, which means it operates in the first quadrant. It operates in the first quadrant. As you can see here, of course, anyway, the current is positive, so I am not going to discuss about again the current output current waveform. But as you can see, the voltage waveform, when CH1 and CH2 are turned on, so here this is the output voltage, and when CH1 and CH2 are turned off, at that time D1 D2 starts conducting. So during this time, the negative voltage is like this. So as you can see, for the full cycle, if the positive cycle is more than the negative cycle, then the average value is positive. So that's why here V0 is positive when T on is greater than T off. T on is greater than T off. Then In the next case, when T on is less than T off, so as you can see here, this is the T on time and this is the T off time. So during the T on, we are getting the positive cycle of the voltage, and during the T off, we are getting the negative cycle of the voltage. And here, when coming to the average value of this particular waveform, here the negative cycle is more, so that the V naught is negative. Anyway, I naught is again positive, which means it is a not second, it is a fourth quadrant operation. It is a fourth quadrant operation. So, which means based on the Tn value, you can decide whether it is a first quadrant operation or the fourth quadrant operation. When T on is greater than T off, then it is a first quadrant operation. When T on is less than T off, then this is a the fourth quadrant operation. This is about the class D chopper. So today's class we have discussed, let me conclude about these all four different types of choppers. So in today's class we have discussed four different types of choppers based on the direction of the voltage and current, right? So as you can see, when compared with the class A and class B choppers, okay, so here class A or class B are a single quadrant chopper, so that's why both circuits having one chopper switch and one diode, one chopper switch and one diode. And similarly, when compared to class C and class D, class C is the two quadrant chopper and class D is a two quadrant chopper. In class C, it is having two switches and two diodes, and class D also it is having two switches and two diodes. Of course, anyway, the configuration of the circuit is different, but the number of thyristors and diodes are same in C and D, because that is also a two quadrant chopper and this is also a two quadrant chopper. Which means if you want to operate a chopper in a single quadrant, then you must have that particular chopper circuit having one diode and one thyristor. And even though if it is two quadrant chopper, then two diodes and two thyristors. And if you go for the four quadrant chopper, that will be having four diodes and the four chopper switches, which means the four thyristors. Like that, the sequence will be. Right? But again, in the of course in class A and class B, both are the single quadrant choppers. So anyway, by operating this switch, so in the class A, it is always operating the first quadrant, and class B, it is always in the second quadrant. But in class C, it is having two switches and two diodes anyway, which means of course just forget about the diodes, and it is having two switches. Then the two switches will decide the chopper should operate in which quadrant. So which means by operating the first switch, then we can operate in the first quadrant, and by operating the second switch, then you can operate in the second quadrant. But unlike that class C, here class D is different. Okay, because the operation of the chopper is decided by the on time, whether T on is greater than T off or less than T off. If it is greater than T off, then it is in the first quadrant, and it is less than T off, then it is in the fourth quadrant. So this is about the four different types of choppers based on the direction of the voltage and current. And in the next class, we will discuss about class E chopper, which is the four quadrant chopper. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.